Welcome everyone, and thank you for joining us today for a webinar about Solargis Evaluate. Let's give it a couple of more moments until everyone joins and settles in, and then we can kick it off. Okay, I think we can start. So those of you who joined just right now, welcome and thank you for joining us today. So on today's agenda, we have a brief introduction to the company, along with some quick facts for those of you who don't know us yet. Next, I'll briefly talk about the feasibility phase workflow and how you can simplify this process with Solargis Evaluate. We'll then introduce Evaluate itself, cover the subscription package, and share some practical tips on how to get the most out of it. I'll also talk about our TMY data, which will be a key focus of today's webinar. And lastly, we'll follow up with a demo so you can see how the software works and why it can make a real difference in your workflow. You can submit your questions through the Q&A panel on your right, and at the end, we'll have some time to answer them. A recording of the webinar will be shared with you shortly after the session, so keep an eye on your inbox. Before we start, let me introduce you to your host today. My name is Dorota. I work as the product marketing manager, and today I'm joined by Miroslav, who is our head of product.
Hello, everyone.
And together with us, you'll be spending the next 45 minutes. Before we dive in, let me briefly introduce you to Solargis. For those of you who aren't familiar with our company, we're best known for our high-quality solar and meteorological data. For a long time, Solargis has been primarily recognized as a data provider, but in recent years, we've grown from being just a data provider to also offering software solutions. And with these combined services, we cover the full PV power plant lifecycle, from pre-feasibility and planning to operation and management. We've been on the market since 2010, and over the years, we've developed our own technology as a result of long-term R&D initiatives that are at the core of our product. The Solargis team has more than 130 employees. We are headquartered in Bratislava, Slovakia, with branches in Canada and Singapore to be able to support our customers from all over the world. Today, we work with more than 1,200 customers in over 100 countries, and each year, our data, software, and services support more than 9,000 utility-scale solar projects. Over the years, we've learned a lot from our customers, and one area that stands out is the complexity of feasibility studies. Here's what a typical feasibility study workflow looks like. In the first step, you have to get reliable solar and meteorological data for your site. When choosing a data provider, you have to look at the accuracy, validation, and uncertainty, and make sure that the data is compatible with the simulation tool you will use later on. Current data providers give you just the data, so you need to import it into the design and simulation tool later on. Once you have your data, you want to create a digital twin of the PV power plant, play around with multiple layouts, configurations, and define the electrical settings. And besides this, you also need a good understanding of the surrounding terrain. You might want to import your own high-resolution topography data. You need to choose the PV components and import the PAN and ONB files. And you also need to consider the environmental losses for the given location. Now, these and many other inputs need to be collected before moving on to the next step, which is the PV energy yield simulation. The goal is a PV simulation that's realistic and reliable so that you can generate a bankable report to confidently approach the bank for financing. As you can see, this siloed approach forces you to use multiple tools for every step. It's inefficient, it's time-consuming, and prone to errors. You have to figure out how to integrate these tools into your workflow, manage different subscriptions, and constantly keep transferring files between the tools because they are not communicating together. That's why each step is represented in a different shape. The situation today is that you can complete all of these steps in one solution. But we have really good news for you because we built a solution that covers everything you need from start to finish. So let us introduce you to Solargis Evaluate, a cloud-based solution providing data, PV design, PV energy yield simulation, and reports in one place. So let's take a closer look at Evaluate. As I already mentioned, with Evaluate, there is no need to use different tools to complete the feasibility study, as we have consolidated these industry standard practices into a single cloud-based solution. Let's talk about the main features of Evaluate. Over the past 15 years, Solargis data have become the industry standard, trusted by the market and backed by our strong reputation. Evaluate provides bankable data trusted by banks, investors, and other stakeholders. We also participated in numerous validation studies, including the most extensive one done by a solar data provider. But you can read more about our data validation efforts on our website in the technology section. Solargis Evaluate works with 15-minute time series data spanning more than 30 years of history by default. Even though we will be mainly talking about TMY data today, it's important to note that our TMY is created directly from the 15-minute time series data. But I'll talk in more detail about how our TMY is constructed later in the presentation. In Evaluate, we provide a full suite of ready graphs, charts, and heat maps that help put the data into context, so there is no need to download it and take it to a third-party software to visualize. We have also developed our own interface where you can create your own PV design in a 3D scene, our own energy system designer. What is great about this solution is that it's cloud-based, meaning that you can collaborate and share your design with your team. You can edit more than 150 parameters and define different types of physical elements that affect the layout. Solargis Evaluate is the first commercial PV simulation solution on the market that uses ray tracing technology based on Perez all-weather sky model. It accounts for the 3D ray tracing technology allows us to calculate for hilly terrains and bifacial panels with no limitation. And to take it even further, we've also incorporated automatic simulation of snow and soiling losses using the Solargis model. It accounts for factors such as panel tilt, wind, temperature, and geographic conditions to deliver accurate results. And this global model is natively built into Solargis Evaluate. And each simulation's results can be turned into a report that is useful for providing complete information for effective communication with stakeholders, as well as securing financing for the project. Today, we're going to be talking about the possibility to create 60 projects with unlimited number of energy systems. For each energy system, you can generate a new report that you can compare the results to see which PV design is most viable for you. So stay tuned because Miro will tell you more in a couple of moments. And you can generate multiple types of reports, including the most extensive one, the full evaluation of PV energy project. All of our reports are based on Solargis data, which have been trusted by banks, investors, and other market stakeholders for more than 15 years. Now, all of these features come together at the project level. So let's take a look at the concept of projects in Solargis Evaluate. In the Solargis platform, you can manage all your projects in one place that you can access from anywhere through a web browser. Once you create your project, it's time to activate it and decide between an early stage or full evaluation. Today, we will be focusing on early stage, so it's important that you understand the difference between the two. Early stage is suitable for projects in the initial phase of PV project assessment. It provides access to TMY P50 data, which give you a balanced overview of the expected performance without the need for time series data. This makes it a cost-effective choice for early decision-making before moving on to a more detailed, high-resolution analysis. The report you can generate in early stage is referred to as technical note, and it is designed to be a preliminary report because it's based on TMY P50 data, as it includes yearly, monthly, and hourly analysis of solar energy potential and climate parameters. Whereas the full evaluation is to be used for detailed, high-resolution analysis for complete evaluation of PV performance. It uses 15-minute time series data, and for projects in the full evaluation stage, you can generate our most extensive consultancy-grade report, which is the full evaluation of PV energy project. The project can be converted from early stage to full evaluation at any time. The biggest difference is that in full evaluation, you get time series data on top of TMY data. That's why there are differences in the capabilities between early stage and full evaluation projects. So let's take a look at them. When it comes to data, the biggest difference is that in early stage, you can only work with TMY P50 data, and in full evaluation, you also get time series data. Therefore, we are able to calculate the uncertainty and interannual variability for projects in full evaluation stage. The same applies to extremes and statistical occurrences, which we are able to give you only for projects in full evaluation. For PV design, there are no limitations to the early stage as you get full access to our energy system designer as well as our PV components catalog. You can create as many PV designs as you want to, and the same applies to running an unlimited number of PV simulations on TMY P50 data for both early stage and full evaluation projects. The only difference is that for full evaluation, you can simulate on time series data, and you can even go up to 1-minute data resolution. And the last difference is in the reports you can generate. As I mentioned, the report you get in early stage is referred to as technical note, and in full evaluation, you can generate the most extensive bankable report. And now with this in mind, Miro will explain what's included in the Evaluate subscription.
Thank you, Dorota. It's been just over a year since we launched Solargis Evaluate, and today, on the symbolic anniversary, I'd like to share some good news. We decided to make several changes and redesign the business model to unlock the maximum value you can get out of Solargis Evaluate. Let me explain. Our cloud-based platform places no limits on the number of users you can collaborate with. With Solargis Evaluate, you can seamlessly work with as many team members as you need without stressing if you hit the user limit or not. You can create an infinite number of PV designs if you want to compare multiple layouts, DC-AC ratios, technology options, or design revisions. You can simply do it at no additional cost. And yeah, you guessed it correctly. The same applies to PV simulations. You can now run as many TMY P50 simulations as you need without using up your subscription or wondering about your license limits. For each activated project, data is already included, and you don't have to worry about having to move data back and forth between multiple tools and applications. Evaluate lets you keep everything in one place. So, no extra add-ons, no per simulation costs, no charge for additional users, no switching between applications. All is included in one price of early stage project activation. And now, as we want to help remove the pricing uncertainty in the industry, we're the first to break the pattern of unclear and unpredictable cost planning. In Evaluate, for 12,000 euros, you can now get 60 early-stage projects with unlimited capabilities. Based on what we hear from our customers, this offering addresses what many teams find necessary in the early development stage. We offer full flexibility of your budgets, and everything you need is included in the price of 12,000. Now, the 12,000 euro subscription plan is just a single price point we are sharing publicly, and we also offer smaller or larger plans to meet different needs. The unlimited options I talked about apply to all the plans. You just get more or less projects you can activate based on the plan you select. And if your organization requires additional projects or a different level of platform usage, you can contact us and we will happily tailor the offering to your needs.
Thank you, Miro, for this explanation. So if we take it into perspective, the 12,000 euros for 60 projects give you one TMY dataset for only 200 euros. And this is particularly compelling given the quality and reliability of Solargis TMY data, which is not synthetically generated from long-term averages. Our TMY P50 is constructed by selecting the most representative months from the available time series. So for example, the most typical January, February, March, and so on are chosen to reflect typical conditions from the full historical record. These months are then concatenated into one artificial and representative single year. In Solargis TMY, the selection of these representative months is done through an iterative process based on two main criteria. So firstly, achieving minimal differences between the statistical characteristics of TMY and the actual time series. And secondly, ensuring maximum similarity between the monthly cumulative distribution functions of the TMY and the time series to accurately represent typical values for each month. Unfortunately, we still see many companies relying on synthetically generated TMY from LTA data, but it also points to a real issue in the market. Speaking of long-term average data, that's where our Solargis Prospect solution comes in. It lets you compare hundreds of potential sites using more than 30 map layers based on solar, meteo, and environmental parameters. Prospect gives you 12 long-term monthly averages for each parameter, which is great for benchmarking project opportunities and a very high-level preliminary PV energy yield analysis. Once the site has been selected and you're ready to move into detailed PV design and energy yield simulation, and more granular data is needed to support financial planning, this is where Solargis Evaluate comes in. Since many of you already use Solargis Prospect, we've prepared a short summary to help you understand the difference between these two solutions and so that you know when is the right time to move from Prospect to Evaluate. So we'll be comparing Prospect with Evaluate for early stage projects. The first and most important difference is where you stand in the PV project phase. Prospect is designed to be used for site screening, estimating solar potential, and comparing multiple candidate sites, whereas Evaluate is designed for detailed site assessment, PV system design, and energy yield analysis. In Prospect, you can collaborate with up to 10 people, whereas in Evaluate, we don't place limits on the number of users. When it comes to data, Prospect works with long-term average data and provides hourly profiles by month. Early-stage projects in Evaluate work with sub-hourly TMY P50 data. In Prospect, you can create very simple PV configuration for quick estimates, and you can adjust simple parameters such as tilt, azimuth, tracking type, and DC-AC ratio. On the other hand, in Evaluate, you can create very detailed PV designs and work with more than 150 parameters. Prospect works with predefined PV components such as PV module, inverter, and transformer. However, in Evaluate, the selection of PV components is much broader. You can choose from a verified catalog of components from manufacturers all around the world, or you can even import your own PV components. So as you can see, Prospect works with a limited set of inputs and long-term average data, which allows the PV simulation to be fast and is well suited for high-level multi-site comparisons. However, when you need to go into more detail, the simulation in Evaluate is more advanced as it employs ray tracing and complex electrical component models to provide estimates of the energy yield. So to summarize, Prospect should be used for fast, lower effort site screening and site comparisons, and Evaluate is designed for high fidelity design and simulation for feasibility stage. We hope this comparison helped clarify where each solution fits within the pre-feasibility and feasibility phases. And now is the time to see Evaluate in action, so I give my word over to Miro.
All right, let's do it. Okay, so in this demo, I'll focus on what we talked about, what you can do and evaluate, and I will focus on the unlimited aspects of that Evaluate provides. So we are here in Evaluate looking at the list of projects, and I want you to focus on the access column, where you can actually add the unlimited number of collaborators I was talking about. So let's just add a couple of colleagues. Yeah, and I could go on and add the whole Solargis here. Obviously, we are not going to do it here. As you can see, there is no indication in the UI, no notification about hitting any kind of limit or threshold. So I could really add as many collaborators as I want. Right. So let me jump into the project itself. And we are going to explore the unlimited number of PV designs and simulations. So moving to the energy systems, and we can see that I've got a couple of energy systems or designs of my future power plant. And for the purpose of this demo, we'll work with the top 3 ones. So let's consider a model situation. I have an original design, which I worked on, and I'm pretty satisfied with it. And I also want to explore a couple of small changes in the original design, and I want to compare them, how they fare with regards of PV out. So let's explore the original design. It's located in Morocco, in the mountains, and yeah, a little bit about the characteristics. It's got 3 segments. One of them is fixed mounting. The other 2 are north-south trackers. And this is my original design. Since I'm satisfied with it, I don't want to change anything here. So I'm going to simulate this energy system, this design. So there are a couple of options. I can choose the data set since my project is activated in full evaluation. If your project was only in the early stage, you could only get TMY P50. But for the purpose of this demo, I will stick with the TMY P50. Yeah. We can see that we have the resolution 15 minutes. And so when I hit apply, I can see the simulation is going to cost me 0 Solargis units. So I'm going to go ahead and run the simulation. Okay, while it's simulating in the background, now the simulation is starting, I'm going to make changes these are just the duplicates of the original design, which now I'm going to adjust. Right. So the first adjustment is I'm going to raise the tilt on the fixed mounted segment to potentially utilize the winter sun better. So the tilt was applied, everything recalculated. And when I hit save and close, the system is saving the changes. Okay, let's go to the to make another change in the original design. And here I'm going to change the module for a more powerful one. So let's pick this segment, and I've got a generic module here, and I'm going to change it. And when I go to the catalog of PV components, I can see various different panels I can choose from. So let's choose this one, as this one was pre-approved by my team. Okay, everything recalculated again. And I'm ready to save this design and close it. And now I can also run the simulations for the alternative designs. That's what we are going to do. Okay, I've got TMY P50. Again, cost of simulation is 0, so let's run it. And we can do it for the last variant, this TMY P50, 0 SGUs. So what we are seeing now, I just iterated on a design. I made 2 changes on the two energy systems. All of them are being simulated simultaneously, and I could go on and make changes, create new energy systems here, and make as many designs and simulations as I want. So I've got a couple of other energy systems simulated. I'm going to use them in a while. Just want to demonstrate that you can duplicate. If you like some system, you can duplicate it and make changes out of that. You can generate a report directly from here. All right, so we can see that the original design is already simulated, and we can have a look at it in the analysis. So I'm in the analysis part of the application, and I'm interested in these PV sections. So we have 3. First one is PV statistics that will give us some information about the PV out specific and PR. We have some. You can also explore the hourly charts and tables. The same goes for PV out total. Then we can explore the system losses. Either we have yearly look at the situation with a table and a Sankey diagram, or we can explore the monthly charts and tables. And lastly, we have the PV long-term degradation here with the production over lifetime and the degradation rate. So that's that. On the top, there is a selector that gives you the ability to select the systems that are simulated and see the results of the simulation just one by one. Yeah. Here we have, if I switch to a system that was simulated with time series, I can see that I have some additional options here. So I don't have just yearly, monthly, or hourly. I have some daily statistics and 15-minute statistics I can explore. Okay, but since we are interested in a head-to-head comparison, or the original design versus the adjusted tilt, I'm going to jump into the Solargis Evaluate technical notes, which are basically the reports generated out of TMY P50 data in the early stage. And I can see that on the left, there is original design. There is the report for original design. And on the right, we have the adjusted tilt one. The reports are going to be very similar since the solar and meteor part are the same. So we can safely jump into the PV section of the report. And the table 7.2, if we explore it, we can clearly see that the original design performs better in terms of PV out specific total and also the PR ratio. So the adjusted tilt didn't really provide more yield as I hoped for. This and the 25-year projection tells us exactly the same, that original design is slightly better. And so yeah, we'll probably stick with that. If I wanted, I could compare also the original design with the swapped panel one, but I think for the purpose of the demo, we got the picture. So as we can see, all the systems are simulated. I could go and explore them in the analysis. So that's it for the demo, and where we just explored the unlimited approach of Solargis Evaluate. And I'm turning it over to Dorota.
Yes, thank you, Miro, for the demo. Let me just share my screen again. Yes, so we have two questions here. So, Miro, maybe you could take them.
Okay. So David is asking if we have a comparison for maybe I'll read the question. Do you have in mind including techno-economic simulation for a complete project's comparison? So the way I understand the question is if you can compare the economy in Evaluate. Right now, you can compare the PV part, and we are working on the economics so that you can also compare money in terms of money, not only the megawatts. Okay. The second question is also for me.
Yes, I think so.
Is it possible to import designs from ACAD? Again, I read this question. If it's possible to import CAD designs, is that right?
Maybe AutoCAD is just a shortcut, no?
Yeah. Okay, so there are some possibilities for import and export, and we can send you the exact way how to do that.
Yes.
After the webinar. So
okay, thank you very much. Yes. So we understood the
question. Yes, so it was AutoCAD, and yeah, there are some options. Yes, there are some options for that.
Good. So since I don't see any more questions, I assume we can wrap it up. So thank you all for joining and staying with us until the end. If you want to learn more or book a demo, you can reach out to us via contact@solargis.com, or you can go to our website to fill in the contact form and we'll get back to you. The recording will be shared with you today via email. Thank you again and have a nice rest of the day. Goodbye.
Bye, everyone.